Alright, welcome back to a new lesson. We're going to be talking about 3.3 and 3.4. We decided to combine these. We're going to be talking about solving systems of inequalities. So last class, or last video, we talked about system of equations. So what's different between systems of equations and system inequalities? Inequalities are pretty much just your less than, greater than, less than or equal to, greater than or equal to. That's pretty much it. If we remember, we have, let's say for example, 3x is less than 5. We would treat this like an equal sign. So we would do 3x is less than 5. We would divide 3. And we get x is less than 5 over 3. Simple. So that's pretty much all we're going to do. And we're going to be talking about how to solve them and how to graph them. Solving by graphing. Which are the following, or which is the solution of the following systems of these two? So I'm going to enable this and label that A and B. Solve each inequality for y in terms of x. So we want to, what this is pretty much saying right here is get y alone. And what this looks like is y equals mx plus b. So let's write it out. A is x plus y is less than 4. So we subtract x on both sides. So y is less than negative x plus 4. And let's look at B. B is 4x plus 3y is less than 18. So we just treat this like an equal sign. So I want to get my y alone. So I'm going to move my 4x first. So 3y is less than negative 4x plus 18. And to get rid of the 3 that's being multiplied by the y, we can divide. So this turns into y is less than negative 4 over 3 x plus 6. So the reason why we got these equations, or sorry, not equations, inequalities, is because we want to graph them. Because our title says solving by graphing. So for us to graph something, we have to make it into a slope-intercept form. Number 2, or part 2, graph your boundaries. Use a dotted line for less than or greater than, but when they have the equal to, we use a solid line. So it looks like this. I'm going to use the green again. 1, 2, 3, 4. And it's negative x, right? So it looks like this. I'm just going to go diagonal. Like so. So like this. Good. The reason why we're using a dotted line is because there's no equal to here. It's missing, right? So I know for sure I have to use a dotted line because it's using one of these inequalities. What about the other equation? I guess I should label this A. The second one is plus 6, so 1, 2, 3, 4, 5, 6. And we go 1, 2, 3, 4, 1, 2, 3. Rise over run. 1, 2, 3, 4, 1, 2, 3. And we're gonna use a dotted line again. Because it has no equal to below it. Oh my gosh. I drew my first graphic correctly. These 1, 2, 3, 4. And it's like this. Uh, 1, 2, 3, 4, 1, 2, 3. One, two, three, four, 1, 2, 3. So I'm just gonna draw it roughly, whatever. Alright. Step 3. Shade the appropriate side of the boundaries. So it says shade above the boundary for whenever the mouth is facing towards the left side, or these are greater than. And shade below if this is less than. So these are less than. So in both of my cases, I have less than. I have less than here, and I have less than here. So I am going to shade them differently. I'm going to use like this. Oh no, it's too dark. What's a tool that I can use? I guess I can use that scrunchy. So anything below it. And the way that I can do that is by looking at... I can look at the line and I can just go downwards. So anything below the line is shaded. Okay. So what about my green or my line A? My line A have to be shaded downwards, right? Like this. So I have to do like this too, and I have to make sure I stay below the green line like that, and I just kind of just shade in, whatever. The solution set is where your shaded region overlap. So in this picture right here, where shaded in both colors. And I'm gonna write this in both colors too. So where is it shaded both colors? It's shaded pretty much from here and all the way towards forever. Like this. and then like this. All of the black area is shaded green and purple. Test the point of the solution to make sure it's right. So let's test one of the easiest points to test right here, which is 0, 0. And what that means test is that we just plug in these values for my x and y. So let's try that. So 0 is less than negative 0 plus 4. That's 0 is less than negative 0, 0. 0 plus 4 is 4. So this is true. But we have to check the other one too. We have to make sure that both coordinates work, or the coordinate works for both equations. So I'm going to take this purple equation and I'm going to plug it in. So 0 is less than negative 4 over 3 times 0 plus 6. So this cancels because it's multiplied by 0. So 0 is less than 6. That's true. So yeah, both of these work. So this point makes sense that it's a solution for both of my equations. So we learned how to do it by graphing. Let's look at the second equation, or the second example. Well, I guess this is our first real example. So what is the solution of the following systems? So we just have to follow those same steps again. There's 3 steps that we have so far. Which I will write this as, what did I use first? I used the green first, so I'll stay true to the green. And step 1 is to make it y equals mx plus b. So for option A, I'm gonna make it 3y is less than or greater, or less than or equal to negative x plus 9, then divided by 3 on both sides. Y is less than or equal to negative x divided by 3 plus 3. And option B, or equation B, inequality B, it is, well, since my y is negative here, I'm just going to move it here and move the 1 over here. So it's going to be 2x minus 1 is greater than y, or y is less than 2x minus 1. Nice. The second step was to graph the boundary lines, as in I need to graph. So this will be step 2 right here. Using the green line, I go 1, 2, 3, and I go 1 down, 3 to the left. 1 down, 3 to the left. This is 2, this is 3. Nice. And I use a solid line because of the inequality. You see this equal to right here? That's why I'm going to use a solid line. Hey, 1, 2, 3. So I'm going to just draw that like that. And then now I'm going to do this one. This is negative 2. So go, well, minus 1 is my my y-intercept, and I'm going to go up 2, 1, up 2, 1, up 2, 1. And I just draw a line. So it's going to be here to here. Nice. And step 3, shade the appropriate sides of the boundaries. So I guess 3 is shade. So since my inequality is facing towards the x side or to the right, this means y is less than. So my graph needs to be downwards, or I need to shade downwards. Y is less than 2x minus 1. I will also shade downwards. Oh man, this is supposed to be a dotted line. So when I shade downwards, I take a random point in my graph like this, and then I just draw a down arrowhead. No moving left or right, just go down. So now I can use my little pencil thing and just graph downwards. Sure. My purple line, I just have to take a point and then go downwards, so I will graph all of this going downwards. So my question to you is, where does it shade both green and purple? Where is a order pair where it is both colors? And that should be like within like this area right here. So let's just choose a random coordinate. And I want to make my coordinate easy. I'm going to choose this coordinate right here, which is 1, 2, 0. And then I'm just going to test it out. Which is what? 0 is less than or equal to negative 2 over 3 plus 3. This is true because 3 is bigger than this fraction, right? So 0 is less than or equal to a positive number. That's true. This is true. Because even if this number is like 0.55, like 0.5 or 0.1, it's still bigger than or equal to 0. Let's try this one. 0 is less than 2 times 2 minus 1. So 0 is less than 4 minus 1. So 0 is less than 3. This works. This is true. So this is my solution right here. So graphing this and telling me like the area of where it is, kind of like this black area, these are all my solutions. I don't have enough space. This is my whatever. You know what I mean. I can't write it sideways. I tried. It's that simple. Let's try this one. This is my equation A. And this is my equation B. Try doing this by yourself, because this one's still pretty simple. I'm gonna show you the solution in 5, 4, 3, 2, 1. Alright. Hopefully you tried it by yourself, but If not, here it is anyways. So option A, well, we know the first step is going to be to, well, the true first step is to graph it, but I can't graph option A. So step one is to make it y equals mx plus b. We have to make it into slope-intercept form for me to graph it. So option A, or inequality A, is negative 2x plus y is greater than 1. I'm going to add 2x on both sides. So y is greater than 2x plus 1. But look at option B. How convenient. This is already in y equals mx plus b. Because I can write y is greater than 1x plus 0. This is still perfectly fine. So step 2 is to graph it. I promise I'm going to do my best to graph this one correctly. They're both dashed lines, Mr. Hong. Go up 1, or yeah, 1, 0 is my y-intercept, and I go 1, 2, 1. 1, 2, 1. 1, 2, 1. And it's a dashed line, or dotted line. And yeah, it looks something like this, whatever. You're fine. And my y equals x line is, my y-intercept is 0, so I start at 0 and I just go 1, 1. 1, 1, 1, 1. And then this is also a dashed line. How nice of Mr. Hong to do this. Mr. Hong cannot draw straight, but I have to fix it. I have to be an example. Alright. So now I have to graph this. As in, you see how my y is greater than, so I have to shade upwards. And this one, my y is also being, or my inequality is facing towards the y, so it's greater than, so I have to shade upwards again. So using the pencil, or this little scrunchy thingy, I can just, I guess I'll do some black. I just take a random coordinate, like here, and I just graph upwards. Or I can even graph here, upwards. Graph, or shade upwards. So like this. Okay, and option B. Inequality B. I keep saying option B, but I just have to shade upwards. So, my little scrunchy thingy is going to help me shade upwards. Just on the purple line. So shading was step 3. So where do my two colors intersect? Or where do my two colors lie? Like what, in what area? Like this. Like this kind of area, like the black area is where I would have both of my things. Notice that I'm using my green line from here, but from when I touch this point right here, I have to use my purple line as my boundary. That looks really ugly, so I'm just gonna erase that. There you go, that's a little better. So let's test a point. Let's do 0, 1, 2, 3, 4. Let's just play it safe and let's just say let's just use 0, 4. So 4 is greater than 2 times 0 plus 1. So 4 is greater than 0 plus 1. That's true. What about this one? 4 is greater than 1 times 0 plus 0. That's true. This is 4 is greater than 0. So yeah, this works. If one point in my double shaded area works, then you can assume that all of these work. Let's try this problem. Example 3. Find the maximum possible y value. So what is the highest y value that you can have in the solution? So nice enough, Mr. Hong has given you two equations, and they look relatively pretty easy to graph. If anything, inequality B would be really hard to graph. And the only reason why is because it's not in standard form. So I need to put my x in the front. These need to switch like this. So my option B is going, or inequality B is going to be y is less than or equal to negative x plus 5. Now I can do step 2, which is graph. This is a solid line, thank God, because I can use the line tool. 1, 2, 3, 4, 1. 1, 2, 3, it's like 1. It's like right here. So I'm just going to use the line tool. And like here, that's good. And a purple one. Negative x plus 5, so go 1, 2, 3, 4, 5 for my intercept, and then I'm going to draw a negative 1 slope that looks kind of like this. And now I'm just going to fill in a line. Like so. Perfect. So this is good now. Step 3, shade. So option A was y is less than or equal to 4x. So I know that I need to shade downwards because it is less than. I'll write that. Shade downwards because it is less than. This one too. I'm going to shade downwards. That statement applies to B as well. So if I take my purple graph and I just graph downwards or draw a downwards line, I know that I can just shade this all purple. Oh, oh. And if I take my black line, or not my black line, if I take my green line and I shade downwards like this, then I know that I need to color in or shade in green below this. Kind of like this. So what is my possible highest y value in my graph? That is both solutions. Wouldn't that be, would that be here? Is this my tallest point where it's both green and purple? No, this is not true. My highest point is actually right here. And that's because both of these lines are equal to, as in these lines are solid. So I can use this point. What is this point? Or what is the y value of this point? It's 1, 2, 3, 4. 1. Well, 4 high, 1 to the left. So the coordinate is really 1, 4. So my max is Well, I will just write it as an order pair. Just to make sure. Pretty simple. Example 4. The last example. Mr. Smith has an iTunes gift card for $15. Each song costs $1.29 and each app costs $1.99. He wants to buy at least 8 items on his gift card. Set a system of inequalities to identify range of possible purchases. So this word problem, the nice way of thinking of this is one equation. I'm gonna make my A equation and a B equation again, because I'm talking about two things. I'm talking about money. So my option A is gonna be talking about money, and wait, I will draw this in green. This is talking about money. And what is the other object that they're talking about that has quantitative value? Or like, how can you, where's like the other number, and what is like the unit that they're talking about? Like, are they talking about feet? No, they're talking about items. I'll draw that purple. So two different things. Your items cannot mesh or be together in the same equation as your dollar signs. So I can write an equation to represent this. As in, I know for sure that this is equal to $15, right? I can write my songs as S, and I can write my apps as A. So 1.29 or $1.29 per song. So per song plus $1.99 per app. Is equal to 15. But what about this? He wants to buy at least 8 items. So does a song count as an item? Yes, it does. If you put a song in your checkout cart in online shopping or whatever, yeah, that counts as an item. So does an app. So I can do song plus apps. How many of these together do I need to have in total? I need to have 8. But I'm not done yet, because I made these as like equal to, or like I made them as equations, but I want to make them as inequalities. So he has $15. So can he spend $15, or can he spend $15 and a penny? He can only spend up to $15. So really, dang, this thing is too big. Let's try 40. Okay, let's try 25. Alright, this is better. That's better. So doesn't that mean that $15 is the maximum that you can have? So wouldn't the inequality be facing towards the 15? And I can put it equal to, because if you have $15, if your price is exactly $15, you have enough. You're allowed to use all of your $15. You don't have to stop at a $14.99. But what about this? He wants to buy at least 8 items. So does he want to buy 7 items? No, he wants to buy more, or he can buy 8, but he can buy 9 or 10 or 11, doesn't matter. He just wants to buy more or equal to 8, like this. So now that I have 2 equations, now I can apply my steps, which is y equals mx plus b. For simplistic reasons, I'm gonna make this my x, and I'm gonna make this my y. So my A equation is going to be 199. Y is, is less than or equal to $1.29, but this is a negative, right? Because we're subtracting this. X plus 15. All I did was subtract the $1.30 X to the other side of the equation. And then now we just divide by 199 on all of this. This turns out to be Y is less than or equal to negative 0.65 X plus 7.54. This is inequality A. So inequality B is going to be, well, let's rewrite it first. X plus Y is less than or greater than or equal to 8. So subtract X on both sides. So Y is less or greater than or equal to negative X plus 8. So yeah, the A equation sucked a lot more, but whatever, you're fine. You're in algebra 2. Step number 2 is going to be graph. So I'm going to, and you better as well. This graph kind of sucks though because we have a 7.54. I'm just gonna guesstimate. 1, 2, 3, 4, 5, 6, 7. Oh, I can't. So I have to make these 2's. 2, 4, 6. I'm just gonna say it's like over here-ish. And negative 6.5, I'm just gonna say it looks like, oh, it's a solid line too because it has an equal to sign. So I'm just gonna make it look like this because we're just guesstimating. Of course, you can just put it in a calculator, but we don't have that luxury when we're drawing it personally. But option or inequality B, we can draw perfectly. 2, 4, 6, 8. And then we're going to just go in negative slope. Like this. And this is also a solid line because it has an equal to right here. Boop. Huh? Whoops. I clicked on the wrong one. There we go. Nice. There we go. And we're just going to assume that these are all straight, perfectly fine. So, which way do we graph my A inequality or my green inequality? I'm going to graph, I'm going to shade downwards because my inequality is facing towards my equation. Remember, these are all facing towards the inequality, or like the mx plus b, so we shaded downwards. We shaded downwards here, so we will shade this one as downwards as well. But look at the purple inequality. The purple inequality is facing towards the y, or it's saying y is greater than or equal to, so we shade upwards from the purple graph. So let's try this. Downwards. And the purple graph goes upwards, kind of like that. I'm going to shade this a little bit lighter. Oops, I missed. I'm having a little too much fun with this, but you're fine. And the purple one, we graph upwards, so like this. So my area is talking about, my area solutions is talking about this small section right here, this little window of opportunity for us to achieve our goal. This area, the black area, which I will draw an arrow, is our solution. whatever. You know what I'm trying to write. I don't need to write all of it. But yeah, that's pretty much how we do it. So today we learned how to solve for inequalities. Systems of inequalities. Remember that systems, this means more than one equation. But instead of equation, we talked about inequalities, which we pretty much just treat as an equation. But instead of finding like where it intersects, we talk about where we can shade and have both colors. So for this unit, I highly recommend that you get two different colors. Kind of like the Joker purple and green. But yeah, I'll see you at the next video. Peace.